first thing you have to do is come up with a picture of how you want the users divided. And then what we'll do is we'll walk through the share scheduling tree, we'll walk through how you can configure that tree, we'll walk through the changes that have to be made to bring up share on the system, the utilities to maintain share, how to look at share and see how it's performing, and then can have questions and answers after that. Okay. As a simple example, let's take a share configuration that divides users into 3 groups, A, B, and C. Let's say they work in department A, B, and C. The share scheduling tree is a pictorial view of how the algorithm looks at the users. At the very top of the share scheduling tree is the root user, and root always gets 100% of the machine no matter what. As we'll see later, you have to be very careful about being root on a system, because if you are root on a system and you're editing a file or you're running a command, with share running, root will consume the entire machine. So system administrators have to be a little bit wary, but we'll look at that later on and ways to get around that. In effect, you never log in as root. You always use SU or you use .f, something that makes you look like root but is really you. Anyway, so he's the owner of all of the resources on the machine. And then what we'll do is we'll have a group A, a group B, and a group C. And let's say that group A will get 25%, group B will get 25%, and group C will get 50%. And that is that over the long run, group A will consume 25% of the machine, group B will consume 25%, and group C will consume 50%. I'm going to leave this picture simple for now. Later on, we'll have to look at how you actually do system administration on a share machine, and there are a few other groups that have to be here in order to make the machine comfortable. But we'll go back and add those in. We'll just get this basic picture, and then we add to it for system administration things and batch. Okay. And let's say group A has a user called Joe and Mary, and group B has Cindy and Lou, and group C has Martin and John and Jim. And we can assign these users percentages just like we assign the group's percentages. So let's give Joe, we'll give Joe 50%, we'll give Mary 50%, we'll give Cindy and Lou 50% and 50%, and these guys will get, let's give him 25%, 25%, and because we like Jim, we'll give him 50%. Okay. So this is how the machine will be divided. When I write 50% here, of course, it's 50% of whatever group A gets, 50% of whatever group B gets, and these are 25-50 of what C gets. So if you want to find out the percentage that any user can consume, just multiply down, and you find out, well, this guy can get 12% at max, etc. If every user was logged onto the machine and was active, these are the percentages that they would get. However, if any, like in Group A, if Mary isn't on in Group A, Joe will get all 25%. Okay? So this is the ideal case. This is when everyone is logged in and they're working. This is what they're being limited to, and that's really what you want to do. Under the current mechanism, if Joe wanted to consume more of the machine, all he'd have to do is introduce more processes into the process run queue, and he would get as much as he wants. Now, of course, he affects himself, right, because he's diluting the processing power of the machine. If everybody here runs one process, then you can have 1/7 of the machine if they have, that's ideal. But if Joe has 10 processes running, well, Joe gets 10 plus 11/17 of the machine. So share, though, limits you to these percentages. And in fact, if group A isn't here, then they would divide this 25% between B and C. Okay, so if we use that as the picture, what we can do now is step through how to configure share to do this. And then after we configure it and you see how to get a very simple model in place, then we'll go back and add it, make it look like a real system. Okay. Before we do that, maybe we should spend just a minute and look at how share works so that you get a bigger picture view. Really, all that share does is if this is the process run queue, this is the ready to run queue, and you have all these processes that are ready to go, process A, and process B, and process C, and on and on. And down here you have the Unix scheduler, and that's the same scheduler that's on every machine. That's the base scheduler. Share sits in the middle right here, and what share does is it adjusts process priorities. So it's really invisible. The Unix scheduler doesn't even know that the share scheduler exists. Since the ready-to-run queue is based on process priority with processes that are higher priority towards the head of the queue and processes with lower priority to the head of the queue, and all that the Unix scheduler does is take off the next one that's ready to run, gives it some time, and then puts it back in the queue. Well, what share does is it comes in here and it plays with the process priority and alters the order of the queue. And then all the Unix scheduler does is take off the one that's ready to run. Share runs frequently enough that it can alter this quickly enough that no one person gets out of hand any particular way. They're not getting too little or they're not getting too much. And that's really how it works. The Unix scheduler is down there. It's just taking things off the run queue. The kernel does run the share scheduler algorithm in order to adjust the queues, but it doesn't do anything at all with taking jobs out of the CPU or putting jobs into the CPU. It just plays around with process priorities. And when you look at all of the things that you can configure in share, one of the things is there are several half-lives. There's a half-life for process priority. There's a half-life for usage, and we'll get into all of those things. But a lot of the parameters that you have in share as a system manager to manipulate is the behavior of the run queue, and so you can affect how jobs are processed. And we can take a look at some of those towards the end. So that's really what it does. So it sits around, I think it just runs like 4 times a second, or once every 4 seconds, I can't remember. And that's adjustable as well. So you can turn it up faster, you can turn it down lower. The one thing that we don't have much experience with is the parameters for share. We know what a few of them do, and they're well understood, and we know how it affects their behavior. There are a number of them that we're not really sure what use they have. And the System Manager's Guide for Share calls those out, and hopefully as we have share on more and more systems, we can say, oh, if you adjust this, then you can expect to see this behavior. But right now, we don't have that kind of expertise. So let's go through and configure share, and then we'll look at how share works on a real system, and how it adjusts the process priorities. There are a couple ways to do the scheduling tree. There's a utility called ShareCF, and there's another utility called ShareSH. And this is show share configuration, and this one is actually configure share. And what these do is they either affect or they take a dump or a snapshot of the file called Etsy shares. And this is the shared database. If it exists on the machine and you have share turned on, then this is the configuration that you are running. Share can be turned on or off. It doesn't always have to be on. There are a few system administration things that you have to be careful of when you start turning it on and turning it off. And you can't just turn share on. You actually have to go down to single user and reboot the machine in order to get your share things to show up. If you make a change to the share configuration, you're going to have to take the machine down and bring it up again. Because if anyone has logged in, we'll go through all this, but share is a kind of you have it all or you don't have anything. You can't say these 10 users are going to be controlled by share and these aren't. They all have to be in share. Now you may give some of them a whole lot more than others, but it's an all or nothing deal. And there are a couple of things you have to do as a system manager to make sure that the machine stays a share machine. Anyways, share CF and share they either configure this, or they just take a snapshot of it, and you can look at it in a real easy-to-read file. To do the previous scheduling tree, what I would do is I create a little share CF configuration file, and it looks a lot like C. And what I'll do is I'll start with S group is equal to A, shares. Let me go back to this picture. Why don't we go ahead and assign some numbers to these, and then we'll carry those numbers forward. The important thing about a share configuration file or a share configuration is that the numbers are not important themselves. They're only important in relation to each other. So if I wanted to give Joe and Mary 10 shares here, and I gave Cindy and John 100 shares here, the only thing that's important is their relationship to each other. If I were to give Joe 20 and Mary 10, then Joe would get twice as much as Mary, but it has nothing to do with these users. Okay? So you really have to look across a level of the tree and compare user to user or share group to share group in order to understand who has what. So I can give Joe 10, Mary 10, Cindy 100, John 100. To accomplish this, I could give 10, 10, and 20. Up here, if I want to accomplish this, I can also give 10, 10, and 20. And root always has just one share. He has 100% of one share. No, just when you compare them, you can see that there's 40 shares total, and this person has 10 of 40, so that's the 25%.
Is that an actual value indication there are 40 shares for a deep level?
No. You never have to say that at this level there's a total of 40. If I were to give this person 20, then there'd be 50 shares, and then this guy would have 20, 20, and 10 is 50, so you have 2/5. You have 20% instead.
Is there any customary way to set this up? I mean, we use 10, 10, and 20. Seems to me like it would be natural to make those be 100% and then divvy them up from 100%. I think the numbers add up to 100.
Yeah, I think that the easiest way to do it is to work in the hundreds of shares instead of the tens, only because you're right, you can easily give them out of 1,000. So give this person 250, 250, and 500, and then you just divide by 1,000 and you get their percentage. It's also a little bit easier to work with the larger numbers when you have to divide them up into smaller and smaller pieces. So.
But there's nothing in particular that's not correct.
No, something that's large, so. 100, for example, on like Arioch, everybody who is somebody on Arioch has 100 shares. And I don't even know how many users there are on Arioch. Some of them have 0 shares, but everybody that's a primary user has 100. And when a new user comes in, you give them 100. So they're equal to everyone else, but I have no idea what the total is. So, no. The numbering is arbitrary, and only their relation to each other is important. So, let's see. If we keep this picture in mind, we've got S group is equal to A, and we can we'll give him 250 shares. And let me do, wait, I think the syntax is name is equal to A, S group is equal to root. The names here, I've tried to be consistent with a lot of the share system administration functions. There are a few that are new, but like S group is one that you can control with the lim utility. Shares is one you can control with the lim utility. So the verbiage for most of this is similar to the already existing share commands. But name is equal to A, S group is equal to root, shares is equal to 250. I'm defining the share group A, and we had, is it Joe and somebody? S is share group. So what I'm doing with the S group keyword is I'm specifying that group A's share group is root. These are all a member of root. These are all a member of A. So let's see, we had, what were the users in A? Joe and Mary. Shares is equal to 100, and then name is equal to Mary, and shares is equal to 100. And that'll completely define the share group A. And you do similar things for B and C. You can do things like, this is a real helpful utility. There's an M shares keyword, and if you specify M shares on this line, you don't have to give any shares here. This says that all of your member shares are this value. You want everyone to be equal, and you can always override. If you put a value here, it'll override this. There's just a few things in there that make it easy to edit the file, put lots of users in, or take lots of users out. And this is a VI-able file. You just bring it up, edit it like you would a C program, and then save it back. If you ever want to see what is currently configured, you run share sh, and its printout will be a file just like this. So you can save that file, edit it, and then run share cf over that file, and you can change the configuration. So these are our complementary utilities. Okay. There is a very small share configuration file for new systems, and when we talk about adding the other groups for system administration, that file describes those groups. And I think there's also an NU file that will create those users if you don't already have them. So there is, and the documentation also has those examples in the paper. But I think for new systems, I don't think that the default configuration just lumps everyone into one group. You have to do a little bit of work to get everybody set up. But it's one command to get everyone in to a particular group. Another thing about this is you can also, there's support for UIDs, there's support for Unix groups. So if you have a Unix group, you can, instead of grouping them all by name, you can also group them by Unix group. And it'll go into the password file and read out everyone who's in that Unix group, and it's just a helpful keyword to pull what you may have set up as ready as groups into share. So, the other, besides Etsy shares, there's a Etsy password, and this was a point of contention for a while when we were working on share. Etsy password and Etsy shares are the two really important files for share. Etsy shares obviously has the configuration. It has how many shares the user has, what share group he's a member of or she. Things like time that the person last used his account, usage values, things like that. From login session to login session, his user information or her user information is kept here. Etsy password is the file of all users on the system, and the point of contention was that even share groups have to have an entry in Etsy password. So you may have an entry in the password file that no one ever uses. It probably should be set up so that that group cannot ever log in. But in order for share to work, you have to have the share groups and the users in Etsy password. So you'll see a lot of the utilities that manipulate the password file, like NU, they will both affect the password file and the shares file. And some people said when we were working on this that they didn't want to have these dead entries in the password file. And we kicked around different ideas about having a separate password file for only share groups and this and that. But the problem is that share works on UIDs, and the only place that you can keep UIDs distinct is in the password file. And you understands what UIDs are being used, and you can look at the password file and find duplicate UIDs, but that's the only way you can guarantee that a UID is unique. So these two files are real important. The password file, as we see in a minute, is going to be used for keeping batch keys for share around, for keeping the network and system daemon password entries around. So when you look at shares, don't be surprised if it tells you to go and create a new user for each share group, because it will. Okay. Given that, why don't we go back to our original example and look at what it would look like on a real machine. The problem that you have is if I allocate the entire machine to users, and remember, root always gets 100%. If I dedicate a lot to the users, or if I keep all of the daemons in as root will consume the entire machine just running daemons. Or, let's say I put all of the daemons in a share group as some users. Well, then they're going to be competing with the other users for resources in the machine. So you have this problem, and the way that we solved it was first of all, we can't run all of these daemons as root. If mail started pouring into the machine, the entire machine would be devoted to just sending mail, because it would say, root's busy, nobody else gets anything. Even if root wasn't doing very much, root would stay and do whatever it had to do. So it may last for 5 seconds or 10 seconds or 30 seconds, but I've been on a lab machine, I've done things like run an infinite loop to see if I've done something correct when I was testing share, and then I couldn't even type. I wouldn't get any echo from the keyboard where I was myself, where I was logged in here as root running this thing. So you can get some real strange behavior. So like I said, if you're a system administrator, you never ever want to log in as root anymore. You always want to SU. And we can look at why SU works instead of logging as root. Anyway, so what we did to solve the problem was we create 2 share groups, 3. One for the batch queues, one for networking daemons, and one for local system daemons. And so the picture you have is you start out with root at the very top, and he always gets 100%. Then we add 3 special share groups called network, I think we called this system, batch, and then everything that we had before, so whatever the users were. For network and system, we usually give these guys some huge amount of shares, just so when the demand comes for resources here, there's enough for them to respond quickly. So typically what we do is we look at how many shares we've assigned to users and assign 10 times that for network and like 5 times that for system. It's really arbitrary. You can go with 10x either. So down here, before we had, I don't know how many shares we had. We had 1,000 shares divided equally, 250, 250, and 500. So I'd probably give network 20,000, and I'd give systems 10,000. And then I'd give users the 1,000. And batch is something we'll get into in a second. Really, when these are inactive, the rest of the machine is doing what the users want to do. When these aren't inactive, the machine is giving some cycles to these, but remember that these are the daemons to do the work of the machine, so it's okay. When you see that you're kind of cheating the users of 100% of the machine. You don't really have 100% to start with. You have this overhead. This is really just overhead. And then the users get whatever's left, but they do divide that equally, okay?
Over what time period do you said, is that tunable?
Yeah, that's tunable. Well, not shares, but usage. Yeah, we haven't talked about usage yet, but yeah, that is tunable. You can turn it down to 60 seconds or as long as a week or 2 weeks. Batch is another sticky subject because of the way that it works. When you set up share and a batch system, if you have a machine that has both share and batch, you need to decide how much of the machine you want to dedicate to batch. And the batch was another kind of sticky point for us. The way we decided to do it was you assign a certain percentage of the machine to the batch queue. Say 20% will be batch. Now, if there's no one running in the batch queues, all that time goes back to the interactive users. Within the batch queue, you create different entries for each batch queue. So let's say on this machine, I want to dedicate 30% of the machine to batch. So what I'll do is I'll look at users, and there's 1,000. So let's say to get to a third, we can give batch. We can give batch 500. So don't ignore these. You have to have these. So you're only playing with batch and users. Let's say I want to assign 1/3 of the machine to batch. So I give him 500 shares as compared to 1,000. Each of the batch queues I'll assign just their like users. And in the system administration of batch and share, you'll see that you have to go into the password file and create entries for each batch queue. And share, batch understands that they have to be there, and the batch daemons look in the password file and do all those right things. So let's say I'll have long and short and very long, and I'll assign very long 100 shares and long 200 shares and short 500 shares. Okay. So I've dedicated 1/3 of the machine to batch. Short has the highest priority within there. It has the majority of the resources, and long and very long. Now, the point about batch that was sticky was batch queues are effectively free for users. The problem that we had is we couldn't have a user submit to the batch queue, get the percentage that batch gets, but charge it back to the user. So what we did was we decided that batch would be effectively free. If a user submits a job to batch, it runs the job as the user, but really as the batch share group. So the user that comes into the short queue can get as much as 1/3 of the machine, whereas he may only get 12% of the machine by himself. first off. And that usage is never accrued to the user. So it really is an incentive for the users to submit jobs to the batch queue. But some people may not like it because they've consumed resources but really haven't ever, they've taken advantage of the machine. I keep wanting to say charged for it, but that's the wrong term because share isn't an accounting system. If you can't use it for accounting, its information is instantaneous. There's no way that you can tell what resources they used. You can tell over a period of time, but it's just too nebulous. And the usage decay is it's not accumulative over a period of time. So anyway.
Talk about the different points of view. Some
Sure.
people contend that defeats the purpose of share. It allows someone to get more than the amount of time that's been allocated.
Right. Right.
The counter to that is if you charge to the individual user, then it's possible to jam the queue by somebody coming to front of the queue and running out of shares.
Right. Right. The secret is that with share, you don't really need a batch system. The reason is that if you look at how users are controlled, every group of users or every user is isolated now from everyone else. I used the example before, like if you have n jobs in the system and I want more CPU than Sharon does, all I do is I send 10 more jobs into the job mix. Well, with share, so what I've done is I've increased n by 10 and have given myself that 1 over n plus 10 more the CPU. I've hurt myself, but I've really hurt everyone else too because I can get as many as I want in there. With share, since it isolates you, since you're only limited to a certain percentage, you're really isolated from everyone else. So if I introduce 10 more jobs into the job mix, all of my processes together are considered when looking at CPU usage. So all I've done is I've diluted my own job mix by 10. If you keep that in mind, the reason for a batch system is to try and keep users to one large job at a time, one after another in batch, so that they keep that isolated from everyone else, right? You run one job at a time instead of 10 at a time, and you get better throughput because the machine isn't crunching on 20 compiles instead of doing one at a time and doing them quickly. With share, since you can isolate users down to their own percentage, they don't ever have to submit anything to the job queue. If they want to do 10 large compiles at once, they can do 10 large compiles at once and it won't bother anyone else. So that's the voice that says, okay, you really don't need batch at all. On the flip side, the reason you may want to set up something like this particular way, is to give the person that advantage of sending something to the batch queue one at a time and getting better throughput. If you know that you've given a ceiling of 20% to the batch queues, that not any more than 20% will be used, then you can give 80% to the users for interactive and 20% over here and guarantee some pretty good response. So you still have the problem of if you submit a very large job to batch, like let's say you submit, now batch itself will catch you, right? Batch will kick you out if you run over your time limit. But if I send like an infinite loop to the short queue, and I have, obviously if nothing else is active, I have a large percentage of the machine. I have 20% of the machine to consume in that infinite loop. I'm going to consume all of this resource very quickly and not get very much. I could sit in that queue for a long time anyway. So, but batch will catch you. Hopefully batch will say, no, you use too much CPU and it'll kick you out like it does now. What is nice about the batch queue is that it resets itself to 0 every time a new job starts, so that you always get real good response, and it doesn't have any history of who has used the batch queue before. which is the problem that you mentioned. If someone comes in, has a large job, consumes all of the batch queue's resources, finishes, and I come in right behind it, I'm not going to get any resources. So what it does is it resets to 0, and then you get fresh started. And so I like setting it up this way. I mean, if I know that I can dedicate X amount of resources during the day to batch, like I could give this 80% and users 20% and force them always to come over here. And at night maybe reverse it where this is 20% and this is 80%.
So if I'm running like 5 jobs out of that short queue, then do they have to divide all the resources?
Yeah. They do. Yeah, so see, I've never even thought about that.
Well, some people do that now. People that you have turn out shares of them, and I thought, well,
That's the
some of
run
them
rate.
will let the short queue have several jobs.
Active at once. Yeah, but with share, that's okay, right? The jobs in the short queue can only get 1/3 of the machine or whatever.
And when all 5 of us are running, they get reset, like when you 6 jobs.
You know, that's a good question. I kind of feel like it's going to reset at this. That's hard. I bet it doesn't do that right. I bet it doesn't have it. Yeah, but I bet it has no concept of width of queues. Mm-mm.
Is it 5 goes through there, does it reset as soon as it?
I think the way it works now is it resets every time a job gets through. So if the width is 5, I bet that it doesn't work quite right. Boy, that's hard. That's really hard. I don't know if the new batch release has this or not, but the way to get around this, there is a utility that lets you run a job as another share user. It's the SL or SLXQT utility. And there was some discussion in one of the notes contact about what to do, and a solution would be if you could let the system administrator run a shell script before every job started, what you could do is you could run the SL command and put that guy back over here. So you'd have interactive jobs over here, and you'd have batch jobs over here, but that would be using his shares, not yours. So it's hard. It's hard. J-Man has always contended that you don't need batch if you have share, because you can keep users isolated from beating up on other users. Okay, so the default configuration file that you get has network and daemon. I think it also has batch and the queues. And you'd have to run NU for network, NU for system, NU for batch, and NU for these guys to create entries in the passive file. So, okay, so we covered this is the share tree, the share scheduling tree, and looked at a default system. What's I going to cover next? We're going to look at utilities for doing some of these things. Passive file?
When you run NU, will that set up the SDCS file for you?
It will. It will. No, I'm sorry, it won't. It assumes that it's there already. When you run share CF, it will create it for you. But NU, on a share system, NU will always ask you for share information. This is this is another funny point too. It's my opinion that when you have share installed on a machine, that from that day that you install share on, you always need to care about share information. You always need to configure for share, because it's all or nothing. Now you may have share turned off, and you can turn off share interactively. The system doesn't have to come down to turn off share. It does need to come down when you turn on share. when you create new users and you're on a shared system, you need to carry the information forward, because if you don't get it then and you don't allocate them somewhere, it's a mess in the future to do it. So NU, if it's on a shared system, will always ask you for share information, even if it's turned off, with in mind that one day you may turn it on and it's better to have that information there than not.
So, but you said it doesn't go in the share?
Well, there's Etsy shares and Etsy passwords. When you use NU, it creates a new password entry, and then it'll go and muck with Etsy shares and it'll put entries in there as well. Yeah, yeah. NU uses these other utilities to get the information in there.
Even if you don't have shares running,
Mm-hmm. Yeah. Now, I think if shares is missing completely, NU won't create it for you.
Like, but if you have shares installed but not on.
It will, yeah. Yeah. Okay. Let's see. So we did share CF and share SH, mentioned those. Let's take a look at some of the share CF and share SH use some utilities to get the information out of the share file. We'll take a look at those, what's available. We'll look at, I don't know all the flags and things to charges, but we can mention that one. And I can show you how to turn it on with charges. There's hundreds and hundreds of flags with charges, or at least 20. We covered batch. There's some things, and all of the manuals have been updated. When you create a batch queue from now on, it will look in the password file, and if its entry doesn't exist, then it says, you can't create this batch file until you go to the password file and do something. That's a small point to mention about batch. You know, in the batch queue, you can assign a name and then aliases to the batch queues. Share always uses the name of the batch queue as the user ID. Right, if I create a batch queue called short, there had better be an entry in the password file called short. And this is another sticky point. Since this name has to be in the password file, you're limited to 8 characters in the name of the batch queue. But you can get around that because you can have arbitrarily long aliases for the batch queue. So that's another tricky thing about it, those two. And that's documented as well. I think that there's an addendum to the batch system manager's guide. I know that there's a separate chapter in the share system manager's guide just dedicated to batch and problems like this. So, yeah, John.
I'd like to go back to the consumption. If I start a batch, if I start a background and log out, it's possible for me to consume my shares such that I'm locked out and cannot log back in because I'm out of shares.
I've never seen it that bad. I know that we've had people who've had 0 shares or have 1 share. For example, for Ariok and Hawk, people started being added as some projects came on, and they weren't getting the share configuration right as well, so they'd get 0 shares. They never would get any response. I don't even believe that they could log in. For a person that has that's a special case. 1 share and 0 shares is a special case, I think.
My thought was if there's some decay rate associated with it, then I might get locked out, but it would only be until the end of that time.
Yeah, I think that you'd be okay. We could certainly try that. Start up the job that's an infinite loop, log out, and I think that you'd be able to log back in. I think that it would give you enough response that you'd be able to log back in and type. You may not be able to get things up very easily. But if your job finishes, we haven't talked about usage. I guess it's a good time to talk about usage. The algorithms for share base a lot of its computations on usage. And usage isn't charges. Usage is a arbitrary number. You assign certain values to, like, CPU. So let's say it's 100 charge units, 100 units, 100 cost. That's your cost, 100, for CPU ticks. So every CPU tick you get 100 added to your usage. And you can also have memory I/O and there's one I always forget. I don't remember. But there are 4 parameters that you can charge for associate cost with. I won't say charge for, associate cost with. And as you use those resources, your usage accrues. And you can look at your usage, you can see what your usage is. Over time, usage gets bigger and bigger and bigger, and that's what share uses to control you. If your usage is fairly high, higher than what it should be, it'll decrease the amount of CPU that you get so that you're back in line with what you've been assigned. If your usage is real low as compared to everyone else or compared to where it thinks you should be, it'll up your process priority and you'll get more of the CPU. So that's how it accrues. Now, how it decays is the tricky thing. Remember, over time, it wants to give you your intended share, whatever you've been assigned. And over time, you'll accrue usage, and the magic is that usage also decays. There's a half-life associated with usage. And the half-life is the period of time that it takes for your usage to be halved. So I can set it, for example, to an hour, which means that in an hour's time, whatever my usage is now, it'll decay to half of what it is. So if you were to run a job in the background, and it would finish, and you came back 2 days later, you'd have it decayed and you could log back in. If you were to set usage for a week, for example, then if you used it really heavily, if you use the machine really heavily for the first 2 days, you may not get much response for the last half of the week. The example, I think it's in one of the papers, is that a professor has an assignment and he gives 2 weeks for every assignment. And if you're a judicious user of the machine and you're a conscientious student, you'll go in and you'll work on the project a little bit every day. But if you wait to the very last minute and you use up all of your CPU, you won't get any for another week. So really, usage defines how the machine behaves over a long period of time, the half-life. Anyways. On Arioc, if you want to guarantee real reasonable response throughout the day, but you don't want to have any one user consume the machine, we set it to like 15 minutes. And when everyone is busy, the machine is well divided. It's not one person doing large compiles is getting the entire machine. And it has a more Unix-like feel to it. If you want to do something like make the user use the machine well over a period of time, then turn the usage up, and then they'll use it a little bit and decay, use it a little bit and it decays. So,
And that's the parameter in the share CF?
No, share CF is just the share scheduling tree configurator. It's actually kept in the kernel, and if the machine ever goes down and you've changed a lot of the parameters, you're going to have to set them again. Or when you turn it on with a set of flags that gives you those parameters every time. So, usage is a term that's well explained in the CX share manual, and it does define a lot of the behavior. There's other parameters to define some short-term behavior of the machine, but usage and the half-life is really what defines the long-term behavior, what users can expect to get. Let's see. Let's talk about some of the other utilities, then we can step back and look and see where we're at. The utility for actually changing the parameters of share is charge. And I think it's charge 8. For example, to turn share on, you do charge minus F 06. And then there's some other things on here. To turn share off, you would do charge minus C minus F01. And charge has a lot of parameters. If you ever want to see what the parameters are, then you run charges. And I think charges is a 1, so that users can look at the system and see how it's configured, see what flags are on, and see what the parameters are that it's using. We can cover a few of the parameters that I know off the top of my head in charts. There's one parameter that's, let's look at the flags, for example, because there are a few flags that really affect the way that this behaves. F06, I think, turns on limb share and this thing called adjust groups. And it also turns share on. Limb share tells share that this person is not supposed to get more or less than this amount. If I make limb share 2, then it says don't ever give this person more than 2 times his share. There may be some cases where the machine just gets into a state where I'm getting a lot of the machine, but limb share controls exactly how much more of the machine I'll get, and it also says how much I should never drop below a certain amount, and that's limb share. So it gives you this kind of delta from your sign share of how much you can lose or gain. Adjust groups is a flag that helps, especially when new users who've not used the machine for a long time come onto the machine. That and limb share together, they work real well. If you've never used your account, or you haven't used it for a week and your usage is 0, when you come into that machine, you're going to get a lot compared to everyone else. If you have other people in your share group who have been on all day and you have 0, then share thinks, oh, now this guy hasn't used the machine very much. Go ahead and give him more of the CPU. And what you'll see sometimes is you'll see these big spikes where John is on the machine, everyone else has been on for a while, and John is doing lots of stuff. So adjust groups will help minimize the effect that has on the machine. Jim? Oh, okay. There could be a little bit of funny behavior. You can see one user getting all of the machine, or it really just it really does. It minimizes the effect of new users coming onto the machine. I think that's what this is meant for. And share on actually turns the share schedule on. Typically what you do is you can turn share off whenever you want to. And then you go back to the old Unix scheduling. But in order to turn share on, you have to bring the machine down to single user. Everyone else they have to be logged off. You can't have any users logged in that aren't part of share. So you need to kick everyone off and then turn share back on. So it's proper to put, if you're going to have share on, to turn share on in strc local. And in fact, the way we have it divided right now is that there's sample files for this. There's strc, which is things that the machine has to do when it's booting, always. Then there's an strc.local, and that's your local RC file. And then there's also an strc.share. And usually strc.local is things you want to do when the machine comes up that's specific, like go and clean temp files. strc.share, it has share-specific things. So lumps the daemons into particular groups, start share up, that kind of stuff. So we just made some logical separation between the RC files. They do get a sample one that they can play with, and all of the sample files are in the System Manager's Guide. But we never messed with strc.local ever. We replace strc ourselves because that's a Convex specific thing. So they're always warned in the release notices they have to go and merge stuff into strc local or whatever. And they have instructions on what to do for share specific things.
Is that a new
Yes, they're in the. I think they're in the release notes. Yeah, the install notes never have anything more than this is how you get it off the tape. So. Is this the break signal? Okay. Why don't we take a few minutes and go through some of the utilities so that you can at least know their names and know what they do if you see them or if you want to read about them. We've already done charge and charges. Another one that's helpful is printf, P-W-I-N-T-F. I think it's a 1. Printf is print share information. And it takes arguments very similar to printf, but the data comes from share. So you can do things really strangely, like you can say printf, can I get this correct? I can say print all users that are in this share group. So I can do things like printf s group is equal to %s, and then s group, or how about instead of this I do l name. It's a syntax like that. It says print this string with this match. So what you can do is this is how you query the shares database and print some useful things. So I want to show everyone who's in the root share group. So see if I have any rogue entries, see if there's somebody in root that I don't want to be. Then I have an easy way of querying the database and asking about things. And it has expressions, so you can say L group is equal to this, S group is equal to this, and UID is equal to this. So this is a real useful utility. Its syntax is a little baroque, but you do it once or twice. I think there's examples now in the printf man page. Another good one is lim, and this is another configure share utility. Oh, I'm sorry. Yeah, we'll get to that one. There's another print one called PL, and PL is print L node information. I skipped over L nodes. I should have talked about L nodes when I talked about processes. Why don't we get through these and I'll go back and show you what an L node is and what relationship it has in the system. But PL is very similar to printf. It just prints a synopsis. So if I say PL, it prints my information. If I said PL Moses, it would give me Moses' information. It's strictly a print utility, and you can use it to do summations, but printf is how you really query. Lim is the utility that ShareCF uses to actually control things. This is how you change things in Share. For example, if I were to say lim s group is equal to root colon shares is equal to 100 and say strike, that command would change my share group to root and assign me 100 shares.
Now, does that take effect immediately, or is it?
You can change shares dynamically. You can't change share groups dynamically. It will complain and say, I think it just says can't change share group. What you have to do is actually go down to single user and make the change effective. Now, if I'm not logged in, I think that it will let you. If I'm active, though, it won't let you change my share group because it can't move your L node around in the share tree to have it happen. So I think that's true. I think that if a user is never logged in, if the person is inactive on the system, you can change anything you want. If the person is active, you can change their shares, and that's it. I don't think there's anything else that you can change. And that does become effective immediately. What else is in Lim? With Lim, you can change share group, the number of shares that you have. You can do things like, say, Lim usage is equal to 0, strike, and that'll wipe out all of my usage. Now, if the user, John asked the question, if a user logs in, if the user can't log in, he types his name and his password, and he just sits there, and he says, I can't log in. So he calls up his system administrator, and the system administrator looks at what's going on in share, looks at his usage, and says, this person, share thinks that this person should get nothing. Then he may have to do something like Lim usage equal to 0, or half it, or something, so that the user can get in. So this takes effect immediately as well. 0 means start from scratch, like I've never ever used anything on the system. And this is a way to get around that problem. If the system administrator wants to do it, he may say no.
So what happens if you assign a user like 0 shares when the settings start?
If you assign a person 0 shares, that person won't ever get anything on the machine. I think if you assign them 0 shares, or 0 shares may not get anything, 1 share gets something only when the machine is idle. If the machine is doing anything at all, he doesn't get anything. If the machine is idle, then he will get some. There's a real interesting utility. It's a little bit difficult to use. I think that the manual has explained how to use it now. There's a utility called idle. I think it's idle 8. And it's a real neat utility. You can actually watch how much idle time the system is exhibiting. The way to do this is there's a special user called, there may be some other special user called idle. The manual says for sure. You start up an infinite loop as the idle user, and if the machine never has anything else to do, it'll give cycles to that idle user doing the infinite loop, and then this idle utility will tell you how much CPU that person is getting. So it's really pretty neat. You can sit on a machine and watch. It has a moving list of what the machine is really doing. It's kind of neat. And I think the manual describes idle. Anyways, Lim is the way to do all of the changes. You can use ShareCF, but Lim is really what ShareCF uses to control things. And you can change share group, the number of shares, the usage. There are a couple other parameters that are numeric, like usage. And this is a root only. Just have to run this is root, and ShareCF has to run as root. PL, all the ones don't have to. Idle, I think, doesn't matter. Idle you can run as anybody as well. So we did charge, printf, PL, lim, idle. There's the rates command, and rates is hard to describe because it's pictorial in nature. The rates utility is what you run to watch how the system is performing. If I wanted to watch how the machine is being divided between users, I'd run rates minus C minus U, and there's another utility called diff. which is a smart little program that watches for changes in the screen and then updates them graphically. And you can use this for all kinds of other utilities. But what this would do is you get on the screen, you get this bar chart. Here's your screen. You get this bar chart of stuff, and over here would be like username, and it moves up and down, and you can watch where the system is spending its time. To test share, what I would do when I was working on a new utility that had to have share folded in is I got on the system, started up rates, used this utility to start my job, and then watch to see if it was being kept track of. But you can come in here and you can say, oh, John is, there's little bangs in here. There's I bars, bangs, and pound signs. And the I bar is what you've been assigned. That's what you will get over the long term. That's your intended share, what the system manager assigned you. The bangs are what the share scheduler thinks you should be getting. This is what you've been assigned, but this is what it thinks you should be getting. If you've used a lot of the CPU, the bang is going to be to the left of the I. If you just logged in, then the bang is going to be to the right of the I. And then the pound marks indicate usage. So the pounds can be on the I, above the pound sign. What the machine will do with the pound sign is it's going to try and control your usage to get to that pound sign. And the pounds are what you're actually receiving right now. So you'll watch this meter go up and down, and if everything is stable, it should stay right on the I bar. But if you just logged in, you'll probably get more. If you've been on the system for a while, the bang will probably be less. Another thing is that if you're on the system, and this is another strange thing that I really don't know how to get around. If you're on the system and you're the only user in your share group, you can consume your entire share group's resources, which means that the next time you log in and there are other people in your group in there, you are not going to get as much. And the rationale behind that says you were on the machine, you were getting more of the machine, so in the long term, you have to get less in order to be so. It's possible for you to consume more than what you've been assigned. It's possible for the bang to be way down here, what you should be getting, but you're actually getting a whole lot more because no one else is logged in your share group. So share is when competition for resources is great, share limits you to your intended share. The key word is competition. When competition isn't there, it's anybody's game. So that's another strange thing, is that someone could come in, get excellent response time, and the next time they log in, get no response at all. We've had people ask us, what can I do to give the machine an artificial load so that I guarantee the same response no matter what time of day it is? Because at night, let's say I come in and I get great response, or in the morning I come in and I get great response, but at night the load falls off and they expect something different. This is one of the field officers said, what can I do? What can I write that can consume resources so that the response is the same no matter what? And it was an image problem. They had some department and some other department wanted to split the machine, and they never ever wanted the users to think that they had more than 50%. So at night, one group could consume the entire machine and expect a wonderful response, but then when the other group came into work the next day, they'd get poor response. So they wanted something for the other group during the night so that it was always consuming their portion of the machine. Anyway, strange thing. But rates is real useful. Now you can use rates to look at users, or you can use rates to look at share groups. It's up to you. The -C flag is continuous display, -U says users. There's another utility called shares. I don't use this one as much. I'm not as familiar with it. But it's another utility that has a graphical display that tells you... it's a lot like rates. Rates has more useful information. Shares will tell you... What is different about shares? I think share does more like a user comparison. There's someone who's the optimal user, and then there are people, and they're all scaled to that. I don't use this one as much as this one. So, rates this share, charges, printf, PL. I think that's it. I think that's all of them. One thing I didn't mention, we can go back and look at Unix also, that I said that share was an all or nothing thing. And what we had to do when we integrated share with Unix is we had to make Unix understand share. And any command in Unix that runs as another user had to be changed so that it would account for the shares. So if you look at what things we did things like cron and at. These things typically run as root. Well, now they run as root. Their usage is attributed to daemon, but when you run a job through cron, it comes out of your shares. So there are other commands that were affected by share. They're not on the share. They're not on the share tape. They're on the standard Unix tape. They work just fine whether or not share is on or off. They don't care. But so you asked the question, what happens if they come in through RSH rather than our login, and it's all the same thing. If they come in, anything that starts a process on behalf of the user has to know about share. So things like cron and at, even something like send mail, this was a hole that I didn't even think of until someone walked in my office and said, you can run shell scripts out of send mail. If you put something in your .forward file, you could circumvent share. So even sendmail runs your .forward file as you. That is for mail coming from the machine to itself. Mail that's coming from outside the machine to the machine gets run as share, but it gets run as a special user because it doesn't know who the user was that sent it, and when it goes from one person on the machine to another person on the machine, the mail delivery actually gets attributed to you. So, anyways, this is a real small hole that we had to fix. But it's neat. You can run infinite loops in your .forward file and get work done if you wanted to. Every time you got a piece of mail. So things like cron and add and RSH and rlogin, login, all those kinds of things. So you'll see, I believe that the share manual calls these out. The release notes for share, I think, also calls these out. The number of Unix utilities that were changed to be integrated with share. And in the X world, things like xterm and xdm also run as share. So anything that runs or starts a session on behalf of a user does this. While we're talking about commands, remember originally I said, don't log in as root ever. You have share on, don't log in as root, use su. And people have said, well, wait a minute, I don't understand. su is root. Well, the point is that when you do cron or add or su, you start the command, and every process that you start is going to be attributed back to you. So even though su is running a process with permissions that are root, it's really your process. So that's why su is better than logging in as root. You may want to disable root login. I don't know if you can do that, and you may not ever want to do that, but the system manager has to remember. If he reads news as root, forget it. That's what his machine is going to do. It's going to read news as root, and that's it. We'll take a step back and go back to that second picture that I drew. We'll discuss L nodes since the share man page, share 5 is the best man page. It'll give you an overview, of share and what L nodes are and how things work. I'll just real quickly go over what an L node is and how share works again. Another big thing about share, and I mentioned this in passing, although I'm sure it didn't come across as clearly, is that all of your processes are considered as a group, which is different from Unix, where they were atomic entities unto themselves. As a user is an atomic entity, and all of the processes that user has, even if I'm logged into 10 terminals running 10 background jobs. They're all attributed to one place. And the place that keeps track of all this is called an L node. And share keeps a whole lot of information in L nodes. And if you have process, like here's process A1 for process A2 and process AN, all of these processes have a pointer back to this L node, and then this is the L node for user A. And then there are other L nodes like that thought. So your entire usage for every single process in the machine is kept in one place in this L node. And when share wants to affect the priority of your processes down here, it'll look at process A1, do some manipulation with its L node, assign a new priority to it. Remember, also there's the run queue runs through here as well, through this process space. So, and the share group information is kept by the order of the L nodes and things like that. But someone mentioned something, I thought, oh, they have no idea how all this is accounted for in the kernel. And all of these things, all of these L nodes are in the kernel. Every so often the kernel checkpoints them into SE shares. When the machine comes down, it checkpoints it into SE shares, and then it sucks all that information back into SE shares, the user information. The charges information, again, it's temporary. If you make changes to the charges parameter, make sure that you put them back into RC local. So then, you can continue the picture. Here's the run queue. The run queue's got all the processes, but they're divided into groups by user. Users have L nodes, and then share goes through and uses the information stored in the L node. One of the things you can do is if you do the PL command, you can actually see how many processes you have that are active, because all it does is it dumps out the information that's in the L node. So this guy would have N. Anyway. So we looked at the share scheduling tree. We looked at L nodes and where the share scheduler fits in. We looked at share commands. We looked at a sample share configuration, integrating it with batch and other system daemons. Some funky things like you can't log in as root. Share is an all or nothing thing. You can't have some users controlled by share and some others not. The password file, the Unix commands. So why don't we talk about typical problems and see what questions come up. After configuring a couple of machines, probably the most important thing you have to do is sit down with a piece of paper and decide how you want your users divided, because it may be a political thing, it may be something that a lot of input has to come in on, because you're really setting a policy for how that machine is used, and you have to implement that policy in the scheduling tree. Typical problems when you set it up, you can miss users, and so they wind up being in, everybody starts out in root, and so they all compete, but then when you start moving them, you may miss some. You can not miss some, but then they get 0 shares and they can never log in. So you got to watch out for that kind of stuff. And the share SH utility should be a way for you to look at and find those problems, because it'll print out everybody that's on the system, and you can look and see who has what and what the mistakes are in that configuration. The other probably big set of problems is if you don't put the daemon into their right share group, you can get some strange behavior. You can either get the machine being totally dedicated to networking, or you can get a machine that doesn't do networking at all, and then it gets worse and worse and worse and worse. Those kinds of things happen.
So are you saying the system administrator, when he or she is setting up shares, is going to have to go in and edit groups or change things that exist on the system or its normal configuration?
They don't have to edit groups or anything. They really just have to edit RCs, the RC file, and they have to edit the password file, and they have to edit or configure the share system, but they shouldn't have to mess with anything else than those three.
What about but you were talking about demons that run in groups.
Right, but those are started in the RC file, so they need to make changes to the RC file. And
Oh, yeah, I remember.
yeah, and what you do is you use the SL command, and what SL does, those are two that we missed, SL and SLXQT, and the arguments to SL are, you do SLXQT. The difference between the two is SL is intended to start a shell, and SLXQT just executes a command. So if I wanted to start a daemon, I would say, and this is a local daemon. Remember, there's networking daemons and regular daemons. I'd say SLXQT daemon minus X etc cron, and that would cron would have the permissions of root, but the shares of daemon. And if you look at the sample RC file, what we do is we do something like set DEA set daemon to be SLXQT daemon, and then in the RC file what we do is like $DEA etc cron. Stuff like that. So you'll see dollar daemon, or you'll see dollar network, and that's an easy way to look at it and go, oh, this guy's in network and this guy's in daemon. And you'll make less mistakes, and it's convenient. So, those are the biggest mistakes I think I've seen that we've actually experienced in bringing this up. And John, you had a question about what did you ask? Well, I mentioned that. Yeah, we mentioned that the users with 0 shares or 1 share.
I think that the documentation kept saying something about people being members of a group called Overhead.
Mm-hmm.
Can you explain that? I can't remember exactly what that was. Or is there really a group called Overhead?
There may the group called overhead may be one of these system things that you have. There's just overhead of processing on the machine.
Because it said some users could be members of the Overhead group or something, and I didn't understand if they were talking about 0 shares or. It made it sound like if you were in a password file and you hadn't been assigned any shares, you were part of the Overhead group, and it wasn't clear to me what in the world that meant.
Oh, I have to go and look. I don't know.
I'll have to go back and see if it's been changed and things.
Yeah. There are a few, like the send mail thing that I mentioned. There is a special group called other, and if the share system ever gets, I think this is fixed with 8.0. It's completely dynamic, so it should never ever run out of L nodes. But for a while, there was a time when you could have more users than L nodes on the system, and everybody gets lumped into other, and other gets idle cycles too. I think that's probably what it was. Yeah, they're not. When we started doing share, there was a lot of cases where users would get lumped into other, but as the kernel got more refined, I don't think I can find a case except for SendMail right now that I know of. And I've tried this because I had the same question about 2 months ago, that they get lumped into other. I know that mail that comes in from another system that gets delivered to you and you have a .forward file, that gets run as other. But
Does it
I don't
mean
know
that
the
there
cases.
doesn't need to be a group called Overhead?
No. That's something that share always has. You don't need to create it yourself at all. I think it has other and idle as 2 groups that it never does anything else with.
I think maybe that's what was confusing there, or did I have to put it on?
No, it's just there. It's just there, and this used to. If you read over the share papers, they never let anybody use C shell. They always had Bourne shell, so there was no job control. So the only way to do gosh, they really needed a batch system for some of this, and they had Bourne. I think that it's a holdover that doesn't quite fit well with Unix, and we've made it so that it hardly ever happens.
So the user, if the user's in the password file and you haven't put them in your share script, what happens to know that?
I think that if they're in the password file and you haven't specifically assigned them anything, I believe that they become part of the root share group, and that they get one share. I think if they're, we can go and look, but that's my guess. That's my guess.
And I think I was reading the documentation saying they got into the group
Yeah. Well, I don't know if that's true or not. I think.
So you can have users on the system who aren't really set up in share.
Oh yeah, you can. That's why I said it's important that you always maintain information for them, even if they're.
Even if you're not letting share.
Yeah, because when you turn it on, you can have this dichotomy between share users and non-share users.
And, you know, you get that, this has been in some package, I think. And I've seen it too, when people have shares on the system but not installed and it gives you that error message, doesn't it go ahead and set up the user anyway? And you doesn't die because of that error message that says something about share.
No, I don't think it does. I think it gives you a warning and says, go and do this by hand at the end. Pretty sure.
Because we've had some people call in and I don't know if it's something they have to go back and fix. Because they said, well, we've got it on there, like here, okay, we have it on there, but we're not ready to use it until we get this error message, and I'm wondering, does it go ahead and add the new users or something? But no share information. I guess I could try it. Do it.
If you have share turned off, I think that it'll go ahead and make the changes. If you haven't ever turned share on, it may be upset. But I don't think it. I think it continues adding into the password file, but it doesn't. It doesn't try to change the. So that would be an error. Yeah, that would be an error. And that would be a case where you would have to go back later and make sure that you had the information for that user added. Yeah. Yeah, use Lin or use share CF and put them back in. Yeah, the person that has 0 shares, we've had this happen on a couple machines. The system administrator really is going to have to get involved. If the person has consumed everything, no, but if the user can't log in because he's never been assigned any shares, then that's another thing that the system manager is going to have to look at. That's what you asked.
Another thing is, what if the system administrator has problems with this and they say, oh, I'm just going to use these default things that you put on the system?
Mm-hmm.
Are they going to be able to do anything on the system?
Uh-huh. Yeah. I keep wondering, I don't think that the default things that we ship actually lump all of the users into one group. But all they would have to do is they have an NU file that'll create batch and daemon and system. And then just one command, and they can add everybody into one large share group, and then they get Unix. They just get Unix. Well, they get Unix, but the machine is equally divided among everybody. So with a little bit of effort, just a little bit of effort, they can get share up and just run share, but not have anything special going on. Yeah. And I think that that's one of the samples in the manual. I have to go back and look.
A guy comes in on the weekend, works his tail off on the computer all weekend long. Is his share impacted during the following weekend?
Yeah. Yeah. The oh yeah, this is true. This is another thing that you can control. Is you can control the costs that are associated with share, and you can change them on the fly. So what you would do in that case, I think, is if the weekend is an off time for the computer, or if there are off times in the evening or early morning, just turn down the cost associated with using the machine, and then they won't be as impacted significantly as if they were charged full. So that's the way to approach it, and that's something that you can do out of the cron file. Put in a command that says charge minus capital C and 10%, and that'll take everything and charge is a bad word. The usage, the cost will be 10% of what it is during the day, and then you can restore it to its original values at 7 in the morning or whenever there are a lot of people in the building. And that's a way to encourage people to use it during off hours as well. But yes, if you use the machine all weekend, when you came back in Monday morning, you would feel an impact. Yes. Everybody else would.
Get a bigger piece.
Yes.
Were these charges accumulated just by the accounting system, or just a share?
No, charges is a bad word. It's really usage is the share word, and it's kept in the Etsy shares file from session to session. Your usage will be recorded in the shares file and also decayed from the shares file. But all of that is kept in the kernel while you're active and in the shares database when you're inactive. I think that you don't want to turn share off ever, really. Like on the weekend, you won't want to turn share off. You just want to turn down the cost associated with using the machine.
You could also go and set everybody's usage to 0, like at 0 hours Monday morning.
You could.
Start every week.
You could.
Fresh. So if they did a lot of work over the weekend, everybody would start with an even.
Yeah, you could do that as well.
Monday. I think that's more of what the two groups want. The load, balancing the load, I think.
Well, the management didn't want one group to think, they didn't want them to get used to ever. They just wanted half the machine. You know, they wanted one CPU to go to one CPU to go to the other, and have it always be like that. So they had some ceiling on performance, really. And strange. So I said, buy 2 machines. I can keep them completely isolated.
Going over all the files involved in system administration?
Password file and the shares database, the RC files. I think I've covered them all. There are a number of man pages that we haven't talked about. There's like LNode 5, and I think there's a shares 5 file. There's a new system called limits, which is a section 2 man page. There's a number of utilities to get information out of the shares database that are in section 3, but all of those should be in the bundle that you get with share. We've covered the management utilities. The rest would be programmer utilities or system information. But there's a shares 5 man page and a share 5 man page, and the share 5 man page gives you an overview of what share is. So if users want to read more about it, they can say man5 share. And then in the manual set, there's a share concepts guide, which discusses what L nodes are, what usage is, what costs are, And then there's the System Manager's Guide for share as well. There's 2 books.